For these first few problems, I can solve them using my calculator if I want to, but if you notice, some of these are in exact form, meaning that they're not decimals. So one thing I can do to help myself is either know my unit circle, which we studied. Remember that we have 0, pi over 2, pi, 3 pi over 2, and then in between those we break up into smaller sections. First of all, we have pi over 6, that's 1 pi over 6, 2 pi over 6, this is 3 pi over 6, 4, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. And we also have pi over fourths. Pi over 4 is here, then 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So if you forget all about the unit circle, you can always use your calculator, but for these problems, notice that these are not in degree mode. If they were in degree mode, we'd see a little degree sign there. These are radians. So if we want to work on these problems in our calculator, we have to put our calculator in radian mode. So you can press the mode button on your calculator and change it to radian mode. When you type in the sine of 5 pi over 6, remember those are the orange ones. We have 1, 2, sorry, you can't see that. You have 1, 2, 3, 4, 5 pi over 6. So right here we're at 5 pi over 6. Sine is the y value, and if you notice, we're not going up very far here, so it's going to be the least of all our possibilities, and it's definitely positive, so we're going to have a positive 1/2 for the sine of 5 pi over 6. So that's going to be letter A. Again, you can also put that in your calculator and get A for that as well. Cosine of 5 pi over 4, or 7 pi over 4, cosine is an x value, 7 pi over 4, this is 0, 1 pi over 4, 2 pi over 4, 3, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Since this is an x value, it's definitely positive because it's in the fourth quadrant. So that means that it can't be D and it can't be B. Also notice that at this place, we are not the furthest away we could be from the origin on the x-axis, because that would be here. And we're not the shortest distance away we could be, because that would be right here. We're right in the middle of those. And the middle value is going to be C in this problem. So C is going to be our cosine of 7 pi over 4. You could put that in your calculator, but you're going to get something that's approximate, something like 0.7, etc. For the sine of 8 pi over 3. 8 pi over 3 is bigger than 2 pi. And the pi over 3 values, if you want to use your unit circle, are here. That's 1/3. This is 2/3, 3/3, 4/3, 5/3, and 6/3. But we need to go to 8, so we keep going around. This would be 7/3 if we come back here, and then this would be 8/3 right here. So it's at the same place as 2 pi over 3. So 8/3 is this spot, and we're looking at a sine which is a y value. It's the highest up we can go on the y-axis until we get to 1, which is the highest. So this is going to be the square root of 3 over 2. It's positive because we went above the x-axis. So this is going to be E. This is going to be letter E. And then for the cosine of 4 pi over 3, remember these are our thirds, so this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So that's going to be right here. Cosine is an x value. We went the shortest possible distance over on the x-axis to get to this point down here. So that means this is going to be 1/2 away from the positive y-axis. But since we're going to the left, it's going to be negative 1/2. So that's letter B. And then by process of elimination, we've used B, E, C, and A. This last one has to be D. Another way to know that this last one is D, because this is a negative 3 pi over 4, we're going to go the opposite direction around the unit circle. So remember, our fourths are the green ones. So this is negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. So we're right here. That's the second furthest away that we could be. So that's why it's negative square root of 2 over 2. So that's how you do those problems. Now for number 6, it says write the following inequality in interval notation. Remember, interval notation is a way to use either parentheses or brackets to indicate an interval. We talked about how you can have an inequality graphed on a number line, and remember we use closed circles if it's less than or equal to, so we're going to have a closed circle at 3, and we used an open circle if it is just less than. So we're going to have an open circle at 4. So this is saying 3 is less than or equal to x, which is less than 4, which means that any value in between those two numbers will work. So we're going to shade everything in between 3 and 4, which means that we're going to have to use a bracket for the closed circle by the 3 and a parentheses because of the open circle by the 4. So that's how you do these problems. That 3 didn't look much like a 3. In number 7, it asks us for the log, or it gives us a function, f of x equals log base 2 of x, and the equation g of x is log base 2 of x minus 3 plus 5, and it's translated. Remember, translation means that we're moving. And so this problem is asking us, how do we move from... You probably remember from Math 1 or Math 2 that having a number added to a function, you can see this one doesn't have that and this one does. When you add a number to a function and it's not added to the x part, it's just at the end, that's going to move the function's graph up or down. Since this is a plus 5, we know we're going to move up 5 from where the original one was. The other way we can move is left and right, and to determine left and right movement, we look where the x is and see what's happening in there. But you also remember that if you're doing anything inside parentheses, it's going to be the opposite of what you would think. So x minus 3 actually means that we're moving to the right 3. It looks like we're moving to the left because it's negative, but we're actually moving to the right 3. So those are the translations there. For number 8, it's asking you about end behavior. And for end behavior, what I recommend you do first is graph these. You can use your graphing calculator and type the equation into y equals. When you do that, you'll notice that the function looks something like this orange squiggle that I just drew. End behavior is talking about where the two arrows are. So one end is right here. And to describe the end behavior for this side, we're saying as x gets smaller and smaller or heads to negative infinity, what are the y's doing? And as you can see, the y values are getting bigger and bigger, so they're going towards positive infinity. For the other end, which is right here, as x gets bigger and bigger and heads towards positive infinity, y gets smaller and smaller and heads towards negative infinity. So that's how you can write your end behavior. And in number 9, it says, in the accompanying diagram, the center of circle O is at the origin, radius OB is 1. So this point right here is at 0, 0, and the radius is 1 unit, and that's labeled for us. And the measure of angle AOB, which I'll trace in orange, This angle is 30, also labeled for us. What are the coordinates of point B? Okay, so this is kind of the unit circle that we saw up top. In the unit circle, we talked about radians before, but the radians correspond to degree measures. So back up here, remember that this is 30 degrees, which was also pi over 6. So right now we're looking at this spot right here, and it corresponds to this spot down here as well. So looking at either of those, notice that the coordinates of that are going to correspond to the coordinates on the unit circle. The reason we know this is a unit circle is because the radius is 1. And this was a unit circle that we studied and took a quiz on. So we just need to know the coordinates of this. From the origin, we go over as far as we can without going to 1, so that's square root of 3 over 2, and we go up as little as we can, besides going 0, which is 1/2. So the coordinates are the square root of 3 over 2 to the right, and 1/2 up.